Welcome to the Albuquerque Journal's Tech Outlook podcast. CNM is truly one college with infinite possibilities in tech and data sciences. CNM offers programs where everyone can learn about software, apps, or how to build websites. You can also choose from AI programs and machine learning, the Internet of Things, and so much more. CNM, one college, infinite possibilities, and the proud sponsor of the Tech Outlook podcasts.
Hi, welcome back to the Albuquerque Journal's Tech Outlook podcast. I'm Ryan Botel, and with me here today is Dr. Mark DelGrande. He's the Chief Technology Officer for Verus Research here in Albuquerque. Doctor, to start, can you just introduce yourself and tell us a little bit about your background and how you came to have this job at Verus Research?
Sure. Thanks for having me today. I started my career out in the Air Force, so I'm an Air Force retiree. Kind of had a unique career in the Air Force in that I started in engineering physics. I'm a scientist by nature. They sent me off to get my master's, and I had my first assignment here in Albuquerque back in the late 80s, where I met my wife. And we started a family and started going around the United States serving the Air Force. That included assignments at like Livermore National Laboratories. I taught physics at the Academy and worked at Los Alamos National Labs, which are very different than most Air Force careers. Mm-hmm. It was the Air Force that sent me for my PhD in nuclear engineering. And my last assignment was back here in Albuquerque, my wife's hometown, and working directed energy systems with high-power microwaves, primarily in models and effects analysis. When I got out in 2005, I went to go work with SAIC, Science Applications International Corporation, here in Albuquerque. It's now Leidos. And worked with what became our founding CEO, Tony Byers, for Verus Research. The two of us were working there, and there was sort of a cultural shift when SAIC went public. I'd call it a focus went from being on the customer to being on the shareholder. And we wanted to put that back in place. So we founded Verus Research in 2014. And the idea was to create solutions that matter, solving our customers' most difficult technical challenges. And I've been the CTO there since 2014.
Okay, and it was founded in 2014.
Yes.
Tell us, can you just give us a little bit of a background on the history of the company? Like, tell us what it was like at the start.
Sure. It's interesting because most startups are coming to the table, actually going to the bank, asking for money to get a startup going. With their thing, with their gizmo, their gadget. We're going to sell 1 million of whatever. That's not what we were about. We were about not creating anything, but providing services to create solutions for our customers. It's kind of odd. We founded our company with the technology and experience we had at the time, which was primarily with electromagnetics, high-power microwaves, and nuclear test and evaluation. So we like to think of ourselves as sort of a development team that starts with low technical readiness level. That's the term that they use in the military. That starts out not quite petri dish stuff that you might find at a university, but concepts and ideas, and then create those up to prototypes that can be actually used in a relative environment or a relevant environment.
Okay, and you talked about providing solutions to your customers. Who were your customers?
All of the vast majority of the work we do is with the Department of Defense. So our focus has been on test and evaluation efforts with the Army, Navy, Air Force, all three services, on looking at capabilities that we can create to help them do more tests on these emerging technologies. We also have a large effort here in Albuquerque with the Space Vehicles Directorate. So we created basically at Verus a platform for any technology to come to the table and start creating. It's sort of an incubator, if you will, of various concepts. So we leverage the really smart people we have, mechanical, electrical, physicists, and computer engineers, and work with them to address different needs that we see across the country, And with space vehicles, we had an individual who came in that understood artificial intelligence and autonomy applications and machine learning for space applications. We leveraged that from one person 5 years ago, and now it's a team of about 10 folks, 15 folks that work with space vehicles on up to now $30 million efforts.
Okay. So back in 2014, there was electromagnetics, microwaves, and nuclear testing and evaluation. Those were kind of the three primary cornerstones of the company.
Yeah, and it was, cornerstones with a handful of guys.
Okay.
That use their expertise. What can I do right now? And so provide advice for newly developed capabilities at White Sands Missile Range, for example. That was one of our first contracts. I think our first dollar was actually supporting new nuclear test capabilities at White Sands.
Okay. And you said a handful of guys. At the start of Verus, how many people were with the company, and what's been the trajectory of the past 10 years?
Yeah, I'd say... Well, it started with a couple folks. So I mentioned Tony Byers, the founding CEO. He got together with Hank Andrews, who's our CFO. Hank was the former base commander here at AFRL, or at Kirtland Air Force Base. And with those two folks, they recognized that they could answer problem or address problems for the customer, and also have the other part that a lot of startups don't maybe think about as well, especially on the science side, is you got to make payroll. You got to have HR. You got to have health benefits and all those sorts of things. Hank was the backbone of the company, providing and ensuring that we met payroll, that we had benefits for the employees on day one, and that we had the processes in place for servicing Department of Defense contracts that could be audited and all the things that the DoD requires. Mm-hmm. Much more like a big company.
Okay. But now today, are you over 100 employees?
Today, yeah, sorry. So today we're over 150 folks. We're about 150 folks across Albuquerque. We've got almost 100,000 square feet of combined office and laboratory space. Mm-hmm. Our main offices sit over off of Uptown Boulevard, next to Coronado Mall. And our major electromagnetics laboratory, we call it M-Lab, sits across from Best Buy, over off a Hotel Circle next to Conn's.
Did I remember that correctly, that it's an old Babies R Us?
It was the original Babies R Us. I mean, I've been here long enough to remember changing diapers.
Okay, so you've been there, yeah. And now that's M-Lab, so it's high tech. That's
right. We started that. We've had a few different starts and stops in different labs and stuff, and I over the years I've gone into these laboratories and go, "There's no way we're ever going to fill this space." I can't imagine that us, all 10 of us at the time when we first got our first lab. It's like there's just no way, and then we filled it up. This was over by Century 24 Theater when we first started our first lab, and we ran out of space, and we were looking all across town. And Hank found and worked the lease with Babies R Us X, whoever owned it. And when we first went into there, it was like huge. And I was like, there's no way. And today we're bumping up against that. Yeah. We're going to be moving into our third floor at the Uptown office now later this summer.
Okay. So when you were talking about your customers, you're talking Air Force, Army, Navy, important for national security. Why is the work that Verus Research does so important?
So a majority of the efforts that we do right now are centered on ensuring that the systems that come to the warfighter operate the way they should, that threats that might appear to our service members in uniform can be addressed. And you mentioned it earlier, I think, with the idea of swarms of drones. So today, directed energy is sort of making a resurgence in addressing the drone attack problem that we've had, and you've seen that on the news in recent battles and conflicts around the world. Sorry. application of directed energy is a key way to not just be shooting bullets up in the air and hoping you can get, when hundreds of drones come at you, that you can protect yourselves.
Mm-hmm. So maybe just to take a step back for folks, directed energy, how would you just simply explain what directed energy is and what power you're trying to harness?
Certainly. When most people think of directed energy, they think of Star Wars and,
Mm-hmm.
pew, pew. Laser systems come to mind because you can see you can't really see it, but you see it on the TV screens or in the movie theaters. But laser energy is light, amplified light. We all know what lasers are, and the laser side of directed energy really focuses on burning holes into things or blinding things with the light that they can provide on systems at very long distances. It's very focused, very narrow, very point solution capability. So I shoot it at a drone when I'm shooting a drone. High power microwaves are more similar to radio waves, and they emanate in a broader beam. And it's also electromagnetic energy, but it's the kind of thing I liken it to if you've ever put aluminum foil into your microwave and seen it spark. Imagine if you could spark a circuit board. Well, you certainly would spark a circuit board if you stuck it in your microwave and burn out electronic components. Now, can I do that not in my microwave, but can I do it across the street? Can I do it a football field away? And so high-power microwaves have really evolved to do that sort of electronic upset, where they emit beams of microwave energy onto targets and insert currents on the electronic systems that disrupt those.
Okay. Is there a sense of taking a microwave and harnessing it to kind of be more direct with it? I mean, is that how the technology works to some extent? And I'm thinking more of lasers, but like you're taking light and kind of shrinking it down into a more direct point?
There are very common struggles and challenges for both those technologies. They require tremendous amounts of energy. They are very large systems, and the challenges over the years have been, how can we make those smaller? There's a sort of a joke in the directed energy community that directed energy is going to be the most transformational technology for the Department of Defense, and always will be, because we're always like one step away from really having that breakthrough to see the capabilities both on the laser side and on the high power microwave side, seeing their use in the battlefield, frankly. That's changing. Over the last many years now, we're seeing systems get deployed and used in various ways in the service. And I think as we learn from those experiences, from operators who are actually using the capabilities, that knowledge comes back and helps us understand how to make those systems better. And often it's not about the energy or the bigger the hammer that you have. It's really about the usability, the functionality, the employability, all the illities that you think of when something's got to go survive in a desert in a sandy environment when it's 120 degrees. And it can't be operated by PhDs. It has to be operated by straight up airmen or other Army folks.
And also, maybe we can clarify how exactly this technology is used to help a warfighter. But so an unmanned aerial system or, a drone, they're being used in battle as a weapon system. They're can potentially fire bullets or a bomb or something like that, or spy.
Yeah, usually they don't shoot. You're thinking, imagine just your regular drone that you might buy at the store. They can be used in two classic ways. One, for the smaller ones, is just to look. I have eyes on target. They can be used for penetrating the lines without using people and actually see where warfighters are. And you don't want those guys around. They can be swarming around a base like flies, just looking and recording and listening. The other ones are more nefarious. They're the ones that have explosives tied to them. And usually you just take those and you launch them into a fuel depot or some sort of vehicle that you might have targeting an individual. And when there's lots of them, they're very hard to defend against.
Mm-hmm. And I mean, one way would be to shoot at them with a kinetic weapon, but this directed energy is kind of allows that drone to be disrupted and taken down without firing a bullet.
Correct.
Okay.
Yeah, so a lot of the technologies are shoot a bullet. It's hard, especially if you're out in the field. How do you shoot a bullet at a thing flying around like that?
Yeah.
It's also hard with a laser system. You still got to put the line. So a lot of the laser system includes pointing and tracking and algorithms that see the drone in the air and help the system fire at it. All those things mean bigger and larger. High-power microwaves don't have the energy that lasers have at distance. So they're more close in, but they're broader. You don't necessarily have to have the perfect aiming on a target system to be able to cause effects on the target in question. And that includes whether it's communicating back to some command controller. Electromagnetic energy will disrupt communications, RF comms, just like if you're listening to a radio and you suddenly go into a tunnel, it just goes out. The other thing it can do is it can attack more than one at a time, which is a nice feature.
Okay. And Verus, located in Albuquerque, the Air Force Research Laboratory, 2 directorates, directed energy and space vehicles, are based in Albuquerque. Is there a pretty good symbiotic relationship between those 2 entities? Do a lot of your contracts come for work with AFRL?
We have some major contracts with both the Directed Energy Directorate here at Kirtland Air Force Base and the Space Vehicles Directorate at Kirtland Air Force Base. For the Directed Energy Directorate, primarily it's about high-power microwave systems. It's developing new and novel technologies. How can you make these systems that I just talked about smaller, more efficient, more capable? One of the systems that rolled out here in the last few years was a system called Thor. We were a major contributor to the development of that. That's a counter-UAS capability that was used. And a lot of our team right now supports testing that goes on with emerging technologies, not just our own, but things that the Air Force is looking at or the Air Force is assessing to learn more about how this electromagnetic energy affects targets and how we can use that in a more intelligent way to cause effects, or how we can protect against it. On the space vehicles side, our primary focus has been leveraging and understanding ways to insert trust and autonomy for satellite systems. So with the emerging number of satellites that are coming on, space is going to get cluttered with satellites here pretty soon. It makes it really hard for operators on the ground to address everything that comes up that a satellite sees. And sometimes decisions have to be made on a satellite system on what it should do. For example, my sensor's looking at the sun. I need to move out of the way. How much trust do you have in giving the satellite control to make those decisions? And so insertion of autonomy is happening across the board. We're supporting space vehicles in doing some of that and also assessing how trusted those systems should be. I liken it to if you're driving an autonomous vehicle through Oklahoma down the highway, maybe you can have your hands off the wheel and you don't care. But if you're driving it down Manhattan, maybe you want to have your hands on the wheels a little more tightly. So you don't trust it as much. Well, where's that line? And how can we remove some of the burden off the operators to do that?
Okay.
The other thing we're looking at is on satellite inspection and assessment. Could we have other satellites go up into space and look and assess a target, not a target, but a satellite system, and then look for ways to maybe even make repairs on that system in space without having an operator be the one on the ground, be the one to do it?
Okay. I mean, that seems like it would be a big advantage to whoever's owning that satellite to trust that satellite to make little changes to keep itself safe.
Yes.
Okay.
Yes.
What are the problems facing satellites in space? Is it the sun's rays, radiation? What solution are you trying to bring to? What problem are you trying to find a solution for?
So, excuse me, the natural environment is always challenging in space. And existing debris, for example, in space, always represent threats to space satellite systems. So that natural activity, those natural environments, always require some action on a satellite system to be done. And today, operators on the ground do that. Mm-hmm. As technologies advance and we understand threats, there are also unnatural threats, adversarial threats that can arise. Satellites being attacked by adversarial countries with laser systems, for example, or nearby satellites that want to do something nefarious to you. So how can you understand when those threats exist? How can you understand the difference between getting blinded by some laser or getting blinded by the sun or some other light source? Mm-hmm. And make intelligent decisions on what to do about it.
Okay. Now, to kind of as we start to wrap things up, can we just talk about the Verus team in Albuquerque, about how many percentage-wise are PhDs, and what other types of employees are you seeking, and do you have just issues with recruiting high-quality talent to the area?
So, I don't have the numbers directly in front of me, but we have a large number of PhDs, or I'll just say a large number of advanced degrees. Mm-hmm. We're really about individuals who are capable of doing the things and bringing solutions to completion, regardless of what their degrees necessarily would be. We've been pretty successful, and I think our size and our growth rate represents and is evidence of our ability to bring in folks not just from out of New Mexico, but within New Mexico as well. We're really about, since our founding, giving back to the community. So, for example, we sponsor the New Mexico Frontiers. You might see it on television, which is an effort to highlight the good things that are happening in New Mexico. The Dinah Theater and at the Natural History Museum, and we're constantly providing support for STEM-related efforts in the state of New Mexico. Mm-hmm. Those things give us touch points with the community, give us, I would say, a platform for people to know us a little bit better, and has brought in a lot of folks from Sandia. And I'll be honest, we lose people to Sandia too. So mm-hmm. there's a bit of a sucking sound over there. We don't do, like I said, any contracts with them right now. We work collaboratively on a lot of different efforts with Sandia folks. And then we sometimes get people from them as well.
Okay. And so you've been with the company since its founding about 10 years ago, and we talked about kind of the growth that happened in the last 10 years. Where do you think this company is 10 years from now?
Well, we were founded in directed energy on primarily high-power microwaves, which is what we knew at the time. Understanding radio frequency energy and effects on electronic targets has moved us more into what I'll say electronic warfare systems, which are maybe lower power but intelligent and smart. We call it cognitive EW, where you can listen to what's going on with the system and then make smart decisions about how you might want to disrupt it. Seeing some of the things, and we're on the cusp of this right now with the Space Vehicles Directorate, actually moving our software concepts and capabilities into space, seeing them on hardware platforms, and then operating in a space satellite that's actually flying. Those are key things on where we're focusing growth and development. We're doing a lot of work right now on developing capabilities. And I mentioned we don't do nuclear, but we create nuclear test capabilities. Up to now, the nation has primarily done testing with single radiation environments. I'll hit you with gammas. I'll hit you with neutrons. We're going to be one of the first developers of a system that can do more than one, and that's going to be going into Crane, Indiana here in a few years. And we're doing basic research, fundamental research right now to understanding the effects of combined radiation effects or combined radiations on electronic systems.
Mm-hmm. Well, that's fascinating. And just think some of this stuff is being researched and developed in an old Babies R Us right here in Albuquerque. So, Dr. Mark DelGrande, Verus Research Chief Technology Officer, thank you so much for coming in today.
I truly appreciate it. Thank you.
Thanks again for listening. If you like this podcast or other journal podcasts, which are free, please consider getting a digital subscription to help support local journalism. You can find this podcast and all our other podcasts on YouTube, SoundCloud, Spotify, and iTunes. Thanks for listening, and remember to read, hear, and watch.